Picture a teammate's agent whose system prompt grew from 80 words to 600 over one sprint. It is now juggling. First plan, then execute, then double check, but only for high accuracy and never reveal internal IDs, and also format as markdown. Quality is sliding, hallucinations are creeping in, and nobody can tell which instruction caused which regression. That is the exact moment to stop adding instructions and start splitting the work across agents. A single chat agent with good tools handles most jobs. Workflows are what you reach for when one agent is not enough. In MF, a workflow is an explicit graph. You wire executors together with edges and conditions, and MF runs the DAG. An executor is any node in that graph, an agent, a plain function, or a custom logic class. And agents are just the most common kind. Let me build the canonical pattern: planner, executor, reviewer. First 3 agents, each with focused instructions. The planner breaks a task into a numbered plan of 3 to 5 steps. The executor receives that plan and does the work concretely. The reviewer checks the output against the original task and replies with exactly one of two things: approve or revise : a reason. Now the graph itself, and this reads beautifully. You start a workflow builder, add each agent as a node, then add edges: planner to executor, executor to reviewer. Then the magic line, a conditional edge. From the reviewer with a condition, if the word revise is in the output, the target is the executor. That single conditional edge is the refinement loop. If the reviewer rejects, control flows back to the executor and the work gets redone. You set the entry to the planner, call build, and run it. Passing max iterations equals 5. It returns when the reviewer finally says approve, or when the cap is hit, because you always cap loops, so a stubborn reviewer cannot loop forever. MAF gives you 4 shapes to compose: sequential, A to B to C; parallel, one fans out to several running at once; conditional, a branch chosen from output; and loop, repeat until a condition holds. For parallel, you add a parallel step of several researcher agents, then a synthesizer node that merges their outputs. 3 researchers run concurrently on the same input, and your latency is the slowest one, not the sum, though it costs roughly 3 times the tokens. Here is the honest test the lesson insists on. Do not build a workflow until a single agent demonstrably fails. Workflows multiply latency, cost, and debugging surface. The clearest sign you need one. The agent's system prompt is becoming a manual. The clearest sign you do not. You can describe the task in 1 sentence and 1 tool list. That is just RAG plus 1 agent. When the work has real stages, encode them in the graph and let each node stay sharp.